Hi math students, it's Mrs. Marcellus and my good friend Gottlieb. Gottlieb lives in the Rocky Mountains in Colorado and is here for a visit. While he's here, he thought he'd join us for our unit where we learn about several concepts that form the foundation for algebra. Today's learning objective: students will write powers as products of the same factor and write products of the same factor as powers and evaluate both by using exponential notation and standard multiplication. We do have some important vocabulary, and the first word is power. Power is a number written using an exponent. It's also referred to as exponential notation. There are a couple things that make up a power. First, we have the base. The base is the number that is the repeating factor. The exponent is how many times that base repeats. Let's look at an example. The 9 is multiplied by itself 4 times. 9 is the like factor, and it becomes the base, the number that repeats. It repeats 4 times, and that becomes the exponent, 9 to the 4th power. Whenever we say a power, we read it 9 to the whatever number it is, power. However, there are a couple of special cases. The first one is when we have a number raised to the second power. We can say the number raised to the second power, or we can say that number squared. For example, 8 times 8 is 8 squared. This comes from the formula for finding the area of a square. 8 times 8 gives us the area of the square, thus 8 squared. When we have a number raised to the third power, we call it cubed. 4 times 4 times 4 is 4 cubed. This comes from finding the volume of a cube. To find the volume of a cube, we take the length times the width times the height. And of course, all sides are the same length, so that would be the number times the number again, or the length of one side cubed. Are you ready to try some, Gottlieb? All right, then let's begin. In our first example, we're going to write the product using an exponent, which means we're going to write the product as a power. The product is the multiplication problem, and we're going to write that in a shortened form. 6 is the base because it is the number that repeats. Then we need to determine how many times does it repeat, and we can see that that would be 5 times, so this would be written as 6 to the 5th power. At this point, we are not asked to find the value, so that is all that you need for your answer. Both fractions and decimals can also be written using exponents. In this case, the base is 5/8. To write this using an exponent, we'll start with 5/8. It is very important that we put a parenthesis around the fraction to show that the entire fraction is included. Then 5/8 is multiplied by itself 4 times, so this would be 5/8 to the 4th power, and we'd write the little 4 on the outside of the parentheses. If we had written 5/8 without the parentheses and put the 4 on top, this would mean 5 to the 4th power all over 8. It would mean to multiply only the numerator and not the denominator. So you want to make sure that you don't forget the parentheses when working with fractions. Next, let's write a power as a product of the same factor, then find the value. To write a power as a product of the same factor, it means we're going to multiply it out. We start with the base, which is 3, and the exponent of 5 tells us that we need to multiply 3 times itself 5 times. So we write out 3 times 3 times 3 times 3 times 3. To find the value, we need to multiply that. We don't just multiply the base of 3 times the exponent of 5. That will give us an answer of 15, which is incorrect. We also do not add. We multiply. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, and 81 times 3 equals 243. 3 to the fifth power is 243. Sometimes multiplication will be written a little bit differently. A dot can be used in place of the x. It looks like this. This will also give us the same answer of 243. If we have a decimal base, the process is still the same. We'll take 1 and 4 tenths times 1 and 4 tenths times 1 and 4 tenths. If we multiply this out, we end up with 2 and 744 thousandths. We can also write fractions as a product of the same factor and find the value. The parentheses around this fraction indicate that the entire fraction is going to be squared. We'll write 1/6 times 1/6. In order to find the value, we multiply straight across. The numerator times the numerator. 1 times 1 equals 1. The denominator times the denominator. 6 times 6 equals 36. The value of 1/6 squared is 1/36. Goats were the first animals domesticated by man in 10 to the fourth power BC. What year is this? In order to determine this, we're going to write the power as a product and find its value. We start with 10 to the fourth power, which is 10 multiplied by itself 4 times. 10 times 10 times 10 times 10. When we multiply this out, we find that it equals 10,000. So the year is 10,000 BC. I'd also like to note, whenever you're working with 10 raised to a power, the exponent tells you how many zeros will be in your final answer. This is 10 to the fourth power, and we had 4 zeros following the 1. Wow, Gottlieb, your family history goes back quite a long ways, doesn't it? To the year 10,000 BC. That's pretty amazing. Well, math students, this concludes our lesson on powers and exponents, so we'll see you again soon.